middle things. I continue to delete. Okay. So what is now my C2? So my C2 is 0, 1 by 9, union 2 by 9, 1/3, union 2 by 3, 7 by 9, union 8 by 9. Function. Its a right continuity is there. Function. Its a right continuity is there. So you see that. And then again you continue to do this. Okay. So if you see now, so C0 is 0, 1, C1 is 0, 1/3, C2 is this one. So what about my C0 intersection C1 intersection C2? What is this? You see, this is a decreasing sequence of sets, correct? This is a, so first step, I take the 0, 1, then I delete the 1/3 of this thing. Then whatever two things is there, 2%, I deleted there 1/3. I take, so I continue to do so. I continue to do so. And I take their intersection. So this is C0 intersection C1 intersection C2. What is this? C2. C2. Great. It is just C2, right? Because I mean, we have done this thing that you have a decreasing sequence of sets, and it is just this one. Right? I mean, so so you see, in a sense, that you will continue this process. So in a sense that there is a formula that Cn at the nth stage is Cn minus 1 by 3 union 2 by 3rd plus Cn minus 1 by 3. I mean, this is my Cn. And you have to run in So I mean for n greater than equal. So in a sense, this also you can write it in this way, that Cn minus one union two plus Cn minus one. This is the Cn. Okay, and you can check that C2 will match this. Okay, so Cn is, and the Cantor set, so Cantor set so you can also write it in like uh, n equal to m to infinity Cn uh, or any m greater than equal to C. And in other words, in words, if you write that, so the Cantor set contains all points in the interval zero one that are not deleted, that are not deleted at any step in the infinite process. So you continue this step. So it contains all points in the interval that are not deleted. Okay? So in a sense that if you continue to do so, delete this one third, one third, one third, you will be, I mean, you can going to take the things uh, in the limiting sense. So it will be just points. It will be almost like points because you are taking the intervals. So for example, C2 is 0 to 1 by n, 2 by n, this way, right? So So in a sense that if you want to I mean, you can write Cn is equal to, it is like 0, 0, 1 will always 1, 3 to the power n. Okay. this union 2 by 3 to the power n, mm, yeah, into 3 by 3 to the power n union I just want to calculate. Ah, there is a mistake here, so it will not be exactly this one. So, so second will be this one, and then so in a sense that it will be it will go like, I mean, the last one will be 3 to the power n minus 1 by 3 to the power n comma 1. Okay. So this is the thing. I mean, Cn will continue to be like this. Okay. So, so but this formula is correct. This formula Cn is Cn by plus 2 by 2 by third plus Cn minus 1 by 3. So this formula is correct. So this formula is correct. Yeah. So so there is one interesting this property. Okay, so in a sense that so you see that what are what are the things you are removing? I mean, Cantor set is those points which are not excluded. Okay, so Cantor set. So you delete those one third, and the Cantor set contains all those points in the that are not deleted. So therefore those points are remaining there. So what is the total length removed? So so you see the length of the so total length removed. I mean, this formula has some problem. This is you may I mean you need something. So probably we'll think about it. So total length remove what? So you see, the first time you remove the one third. Second time uh you are removing 2 by 3 square. Third time you are removing 3 by uh, uh So in a sense that uh, uh, okay, I'll come to this. I'll come to this later. So in a sense that what is my C? So my C is nothing. You have 0, 1 interval. Okay. And then you are deleting what? You are deleting, mm, okay. Mm. So these are the portions you are deleting, every middle part. When k equal to 0, sorry, when k equal to 0, then you will then this is just one I have written something wrong, which is then this is 1/3 and 2/3. This is what we are I am deleting, right? I mean k equal to 0. correct? 4 by 3 cube uh, plus n equal to 3. So that is 8 by 3 to the power 4. Or I can say something like 2 square. Similarly, this is 2 cube plus whatever. So you see, this is geometric series, right? This is geometric series. And this is geometric series, and I can write the formula for this first term one, third, and the difference is 2 by 3, right? 2 by 3, 1 minus r. And yeah, and this is 1. Okay. So in a sense, the funny part you notice that you are removing the total length of the one, and you started with the 0, 1 interval. So in a sense that what is the proportion left? I mean, because the length, so you started with 0, 1 interval, and you are removing gradually the length one. So in a sense that, mm, so the proportion left is 1 minus 1, right? It is 0. So in a sense that you are removing the whole thing. So what you left with a certain points in the 0, 1 interval, it will be, I mean, very small intervals which will be there in the 0, 1. I mean, sorry, you continue to remove these parts, and you will be left with just very discrete things, very discrete points. Maybe 0 will remain, and uh, so 0, 1 will remain, and some points in between. So in a sense that you are removing the whole thing by doing, because it's a geometric series, the removed length is 1. So in a sense, and again, it is saying that this is contains intervals. So these are small intervals, which are almost like point something. And so this is a very interesting this thing. I mean, it contains interval of no length. I mean, so in a sense that Cantor set contain any interval of non-zero length. And so if you see the point, so zero, so whatever is there, so you will continue to, so these end points, like, so next step you will again divide it by these intervals in these things, right? You will divide these intervals in these things and remove the inside parts. So you remove these parts, you remove these parts, you remove these parts, you remove these parts. Okay. But you see, this point 0, 1 will continue to remain. The end point what you were there, like 2/3, like 2/3, 1/3. These endpoints will continue to remain 1/9, this 2/9, 1/3, 2/3, 7. So in a sense, the Cantor set will left with, I mean, those infinite, uncountably infinite number of points. Okay. So the endpoints continue to remain. I mean, this 1/3, 2/3, this. So in a sense, that so it's a non-empty set. Cantor set is non-empty, and contains